Okay, guys, let's pick up where we left off, and let's do another linear inequality that has maybe a slightly more degree of difficulty. The first thing that you probably notice with this inequality is we've got fractions. So just like with linear equations, we can clear fractions by finding a lowest common denominator, least common multiple. So for my denominators of 10, 5, and 4, there's a handful of ways that you can come up with the LCD. You might just be able to look at it and recall some multiplication facts. If that's not your forte, if you can't just like look at that and go, boom, 20 is gonna work, then another way that we can do this is we can start with the largest denominator. Okay, so currently my denominators are 10, 5, and 4, and of course the largest of those three is 10. So I'm gonna start with 10, and I'm gonna sort of list all the multiples of 10, and I wanna find the first one that's gonna be divisible by, of course, 10, but also 5 and 4. So if I do 10 times 1, I get 10. And I know 10 is divisible by 10. And I also know that 10 is divisible by 5. But if I try to take 10 and divide it by 4, I don't get a nice clean whole number. So that tells me 10 doesn't work. So then I go to the next one, 20. And actually, let me just go ahead and list this out. 30, 40, and so on. So I've eliminated 10 as a possibility, but then if I try 20, is 20 divisible by 10? Of course. Is 20 divisible by 5? It is. Is 20 divisible by 4? Bingo. So we've got it. My lowest common denominator is 20, which means if I take all of these terms in this inequality and multiply them by 20, I'm going to end up with something that's nice and clean and fraction free. So let me do that. So 20 times 3x plus 10 divided by 10 plus 20 times x over 5. My inequality is going to say less than. Don't forget, if we ever multiply or divide by a negative number, then we have to reverse our inequality symbol. But we are multiplying everything through by a positive 20, so no need to flip anything around. Okay, so recall the whole point of this. The reason I'm multiplying by 20 is because I want to get rid of dividing by 10, I want to get rid of dividing by 5, and I want to get rid of dividing by 4. So with that in mind, I know 10 will go into this 20 2 times. So that 2 is going to be multiplied by the remaining numerator. It's not just 2 times the 3x, but it's 2 times the 3x and the 10. Put it another way, I might benefit by writing this as that leftover 2 times that leftover numerator, 3x plus 10. If you can go ahead and distribute that, cool, go for it. But let's go back to clearing fractions. 5 goes into 20 4 times, so that leaves a 4x plus 4x remains less than, and then 4 will go into 25 times, and again, that's a 5 times that remaining x plus 1. And there you go, step 1 done. I was able to successfully clear fractions. But now I've got a whole lot more cleanup to do. So before I can isolate x, I'm going to have to simplify, and simplify means not clear fractions. I already did that part. Get rid of parentheses by using the distributive property and combining like terms. So I'll simplify the left as much as possible, starting by distributing this 2. 2 times that 3x is 6x, plus 2 times that 10 is 20. I still have that plus 4x, still greater than. Next up, likewise, let's simplify the right side by distributing this 5. So 5x plus 5. I've gotten rid of all my parentheses, but on the left side, I have the 6x's and the 4x's, which are like terms that can be combined. So 6x's plus 4x's is 10x's, plus that 20 is less than 5x plus 5. Okay, so I'm out of space. Let me go to the next slide. Okay, so I've simplified the left side as much as possible. 10x plus 20, those are not like terms. They can't be combined. Likewise, 5x plus 5. So now, how do I solve an inequality when I have the variable x on both sides? Same cardinal rule of algebra as I can eliminate anything I want from one side by adding or subtracting it off as long as I do the same thing to the other side. So notice, if I choose to, let me just change this pen color for a moment. If I choose to subtract the 5x's off from the right side, I'd have to do the same thing to the left side. I don't have to reverse my inequality symbol in this case because I'm not dividing or multiplying by a negative number. So I have 5x plus that 20 remains less than the zeroed out, leaving that 5. And now we're almost back to autopilot. So I'm going to go quickly through this. I'm going to subtract my 20. $5x is less than 5 minus 20 is negative 15. Last step to isolate x is I have to divide by 5. But again, we're dividing by a positive 5. So even though on this right side we're going to get a negative 3, I divided by a positive number. So less than stays less than. The 5's cancel out to 1. 1 times x is x. Negative 5 divided by 5 is negative 3. And I want to write my final answer in interval notation. So quick graph. Negative 3 is going to be right about there. And if x can be any number that's less than negative 3, that is everything to the left of negative 3, but not including negative 3. So I'm going to parenthesis that up. So my interval notation, final answer, left to right, what's shaded? My shading starts at negative infinity. Infinities always get parentheses, comma. Where does my shading stop? It stops at negative 3, parentheses. And that's my final answer. Okay, that was fun.